Hello, everybody. I send you many greetings from my hometown, Erfurt, and I'd like to present today a live session concerning the command line tools reloaded. I will switch off now the video because I need all the screen to show you all the nice commands we will cover in the next hour. My talk is a continuation of the talk in the year 2018. I did held a similar talk already at the conference in Mexico, and via this link you can download this talk, and I recommend everybody who didn't attend this talk to download the talk and show what is it about. And as I said already, this is a continuation of the 2018 talk, and I want to provide you with updates regarding the universal rendering development environment and focus especially, of course, on 3.20 and 4.0 and what came into the house since the last version. I simply start with VI. I did read with a great pleasure that a lot of you are using VI and of course are using also Vim. And I try to cover some features for Vim today. One of the Vim greatest features is the Control V command to mark blocks in your code. And this is especially very useful if you are in the .perf file. So I'm going into this main.perf file. And you see a couple of form fields below each other. I press Control V, and then I can have a block selection. And this block selection I can expand. And then I can press D, and all this is magically indented. And of course, I can also use Control V to mark the block, yank it, and put it so that you can extend the whole block here. So you see, it's a very powerful command to edit your forms. You can, of course, use it also to go into a 4GL file. I could go to a certain function and mark with the Control V command also a block, for example, until the end of the function. And if I have defined a mapping for my formatting, in this case, I have the function key F4 defined to format the selection of the block. This is a very useful usage of the visual block selection in Vim. Back to our slides. Over to the Genero Vim plugin. I did introduce the Genero Vim plugin in my 2018 talk. And of course, you can read a lot also in the documentation. Since the 2018 talk, there came in several new commands. And one of those interesting new commands is the lowercase keyword configuration in Vim. The FGL underscore lowercase keyword variable is a Vim variable, and if you set it to 1, it configures that your keywords in lowercase are syntax highlighted, and that you also get a completion, a source code completion for the lowercase keywords. How does it look like? I'm going into a file having completely lowercase keywords. You see, they are not completed and they are not syntax highlighted. I go in my vimrc, enable the flag, go back. Keywords are syntax highlighted. And if I insert a keyword and press the completion tab, then you get a lower word as a completion, as the syntax, as the source code's completion for util, for example. Going into my vimrc, next, enable the next flag. The next flag means you can still see the syntax highlighting for lowercase keywords, but if you press the completion character, such as tab or Control XO, then you get the completion for uppercase keywords. And again, my file, still the lowercase keywords are syntax highlighted, but if I now insert a keyword, then it's shown in uppercase. So that is the purpose of the flag. Switching back. Vim has its own language called VimScript, and FGL format is a VimScript function and is located in this directory $FGLdir vim files syntax fgl.vim. The function acts on a Vim range and, of course, is depending on the .fgl format somewhere in your file hierarchy. We have 4 Vim definitions here, and this definition maps a function key to a certain functionality. The first one is I format the current line. The second one is I format a range of lines, and this range of lines can be selected with the V command or the Control V command as shown previously. In this command I say I want to format the whole file. The % means I have the whole file. And last but not least, there is a nice definition which searches backward for function and forward for the end of function to format the complete function your cursor is in. Again, small demo. I'm again in my little sample file. I'm on this line, I press F4, and only this line is formatted. Obviously, I use for the formatter uppercase keywords to make it more visible here. Then I say I want to format a certain range. And I press F4. Okay, seems to work. Then I press F5 and it formats the whole file. Undo. Last, I go somewhere into a function and press F6 and this function is highlighted. Undo. If I'm not in a function, for example, I'm between those two functions and I press F6, then you see it searches backwards to the function and to end of function. So that means I have now 2 functions formatted. Of course, the macro could be enhanced to make this more fail-safe. Okay. Going back to the slides. If you are working with Git and you use FGL-comp to format the source code, and you want that all source code in the Git repository is always properly formatted, then FGL Git format is a very nice Vim function, VimScript function, helping you to format only those lines which have actually changed in your editor. On the command line, there's the FGL Git format tool. You could use this tool, for example, in Makefiles to add a certain rule to do that. But in Vim, you have this FGL Git format function. You can map it to a certain key, here in this example, the F8 key. And then if you hit this key, only the lines are formatted which have changed in comparison to the repository content. Small demo. Going back to my file. I modify, for example, the signature of this function. I'm adding a line here. Now, if I make a git diff of this file, then I see, okay, those two lines have changed. Then on the command line, I could use FGL git format to show me what would happen with the formatting of those two lines. FGL git format. Okay, FGL git format tells me it would format those two lines with an uppercase keyword. Now I could use FGL git format to apply this formatting with the -i switch. FGL git format -i file utils.4gl. Running git diff again. Okay, it did apply the formatting. And now I could have this also in VI, in Vim. Just check out again to have a fresh copy of file utils. Go again into file utils. Do my little changes. Define int. And now I hit F8. And I can do it just with a little shortcut in Vim. Okay. Back to the slides. Vim helpers for refactoring. Since 3.20, FGL-Comp has new options for assisting you in code refactoring, and Vim can make usage of those helpers too by defining little wrappers, and you can map those wrappers as usual with a function key or to a function key. One is the FGL-Comp ---- fixed case. This is very new since 4.0. Second one is qualifier imports, already available since 3.20. And the third one, mark host variables, also new since 4.0. If you want to know exactly what those options are doing, please check the documentation. I just show now a little sample how to use it from Vim. For the first one, switching to my sample, I'm going to my file utils.4gl. I try to make now the project, and I get a lot of warnings because I'm compiling with 4.0, case considerations, expecting channel. This is probably all of you got those warnings if you jump to 4.0. The reason is that base or channel has not the right case compared to the definition of what the compiler expects. Looking for the next error. Case considerations, warning, expecting open pipe. Now I have mapped the little code refactorer to F10. I hit F10 and the code refactorer did change the open pipe to a pipe with a big P and delimiter, base or channel with a big C. So that is this functionality. Please know that those helpers are not working if you are calling them on a file which doesn't have any changes. I type F10 again, and then everything is lost. This happens if the FGL-Comp ---- fixed case doesn't find anything to change. So the macro isn't really fail-safe, just in case to warn you. Undo, but we can visit the results of our case tool, of our refactoring tool, and see it did do the job for us. Of course, you can call it from the command line, much more reliable if you put it into a makefile or have a batch file to organize your refactoring. It is, however, nice if you have this F10 key on your fingertips, you are in a file, you compile with follow0, you are annoyed by the warnings, you hit F10 and the problem goes away in this minute. You don't need to write a batch file, don't need to write a make file, just use this little helper. Okay, after I have shown so many function key definitions, the question may arise, how can I remember all those function keys? The answer is very simple. You need to remember at least the :map command, and the :map command helps you to show what is the current mapping of the function keys, starting in reverse order, I don't know why. F12 appears as the first entry and F1 appears as the last entry. At least this gives you a short overview over your function key mappings. That's it for the Vim helpers. Going back to the slides. Vimdiff is a very nice tool to work with Git because it gives you a side-by-side comparison of your differences you have done in your source code, and all you have to do is to tell Git that Vimdiff is your diff tool with these magical command. Git diff tool invokes the tool, and the following command lines configure this in a either global or not global method, depending on the -- global flag is set. And just let's try if this works. So I have a Vim repository here. I make a git diff, and I have a git in the diff in the file. This is the normal git diff. And if I call git diff tool, then you have a side-by-side comparison of your changes. This is a little bit more visually, and you can scroll to the file. You can then edit one of those. You can go to the left side, right side, and this is very handy. And I often use it when I have a really complex diff to understand, and there's many source code lines affected. So git vimdiff is your friend. You see also the repair files. Pretty nice, can recommend it. Usage of -fglcomp dependencies. There's a new flag in fglcomp which helps you to create dependencies in makefiles. And all you have to do is calling fglcomp -dependencies on a set of 4GL files. And what you see here is a makefile making use of that. The trick in the makefile to have those dependencies is that you include those dependencies with the minus sign. Here you see the minus include depend means the depend file doesn't need to exist. Only if the depend rule has been called, then fglcomp -dependencies creates this file and then make knows the right dependencies. And you see a sample if you would have a file called main.4gl and it depends on a file called m1.4gl. If you have an import in main for the m1 module, then the fglcomp -dependencies would create this dependency and have this in the depend file. And very handy is that you have, since 3.20, you might have circular dependencies and you are normally not able to express them in make, but the tool, the fglcomp -dependencies has found a very sleek rule to circumvent somehow the circular dependencies. Normally, if in make you would say A depends from B and B depends from A, make would tell you that this is a circular dependency and it would terminate. But this barely understandable rule solves that somehow, and the tool creates it for you. This we could watch live. depend. So we have a file called a.4gl, and it imports a module called b. It calls from b some functions, and in the module b, we call some functions from module A, so we clearly have a circular dependency. And then in the module main, we import both of them. You see here the make file. I just wipe out that here to see what it's really about. Call make. And we cut depend. And he has created this dependency. Make clean. Make he compiles first A and B, and then he compiles main. And then if I touch, for example, a.4gl, call make again, then he knows he has to compile A and B and main because all of them depend on this. And if I touch just main.4gl, then calling a make again, make, then it only compiles the main. So it's handling this nicely. Or hooray, hooray. For those who never used make before, there is meanwhile a fglcomp -- make switch. And this means you can just call fglcomp with this switch, and it magically does the same things intelligently like make. It knows the dependencies, it doesn't need a dependency file, and it's a single command line. So that's even easier. And of course, a very, very nice invention since 3.20. So if I have those three files, I can say fglcomp -- make star.4gl. Nothing to do. Touch a.4gl. And fglcomp does this for you simply by analyzing the dependencies without any dependencies files. And if you have a large number of 4GL files, this can be even faster than make. But if you have told your make to do parallel builds, then make still will be a bit faster. Depending also if you have circular dependencies or not. If you have no circular dependencies, make will be faster if you call it with parallel builds. Now, this is some kind of main topic for this talk, is we now have the new web world with the GBC. This is now our state-of-the-art client. And what do you do as a developer when using SSH or when being on the desktop using the command line? So there are plenty of possibilities, and I have read in your polls that you have a lot of configurations, and it sounds like every configuration is possible. You can have Windows clients, you can have Windows servers, you can have Mac client servers, and so on. You can be local or remote. So I try to give you a little path through the jungle, what you could do. The first thing is, of course, if you want to develop with the GBC, then you can use the GDC. And the GDC in version 4.0 uses the GBC by downloading it magically through the FGL GBCDir environment variable. And it makes no difference if you are working remote or local. You just need to set FGL GBCDir, and you can call your program with FGL run, and it pops up in your GDC. So that is, of course, a very easy opportunity to work with universal rendering. And if you want to deploy also the final app with GDC, then all is fine. You just need a GDC. But if you want to deploy also via GAS and in real browsers, then of course you need at some point to test your program in the real browser. And there are really differences between the browser and GDC, because the GDC is using the Chromium engine and a special version of the Chromium engine, the Qt Web engine. The point with the Qt Web engine, that is always some versions behind the Chromium engine. This makes it sometimes difficult to catch up. We have some bugs, and it's always recommended, if you want to deploy in the browser, that you develop and test in your real browser. So that's why we try to cover this now in very much detail, what you can do. Yeah, a caveat is that some front calls which are working in GDC will not work in the GBC. So you cannot simply go on like you did with the GDC in the past years. If you do have those front calls, you need to work around them if you want to have a purely web-based program which doesn't need those front calls, the execute front call and the shell exec front call, and some other front calls regarding the communication with Excel and DDE and all those. So you could, of course, have it in mind if you develop with GDC, but if you really need to deploy it, then of course, there's no way around to use the browser. The first thing, of course, is if you need to use the browser and the GPC, you need to use the GAS. I don't cover here what you have to do if you do normal GAS development. Normal GAS development, I would call it, if you have your GAS installed the way it's recommended, then you have your XCF files, you need to edit your XCF files, and you need to type, or you have then some URLs to type in your browser to connect to the GAS. This is easy, but it isn't that easy. For me, it was always the point that if a new GAS version did arrive, or my XCFs were not in the right place. I needed to recreate them, and that's why it was too much manual work for me. So here you see a little deviation, what you could do. That, one point is also, I wanted to see always my output from the display statements, and by default, those display statements are not visible on the standard output. They are lost somewhere in the config, in the logging files of the GAS. And to make those statements visible, you can use this long, lengthy command line to see your GAS output on the standard, to see your display output on the standard output if you start the GAS in a terminal. You could start, of course, a GAS on the command line. You could let its output to standard output, and you could have your own app data path to not collide with any central GAS installation, which might be on your development server. But what I wanted to say here with this slide is that you can start your GAS also at a certain port offset. The normal offset is the 94. That means it starts on port 6395. So if you have a private GAS set up, then you can have a private port, of course. You can connect to your remote host on this remote port, but it isn't fail-safe because other users on this machine might have invoked their private GAS already also on those ports. So that means you would need to collaboratively manage the GAS port numbers. Then one might accidentally use a port number in the browser a colleague uses, and then the colleague gets your display output, or the firewall of the dev machine might block. If your dev machine is firewalled, then you need some additional rules to set up the port forwarding to this private GAS. And you could do this with an SSH -L port forwarding command. And then you could point your browser to your local host machine, and the local port forwarding would then port forward to your development machine by this SSH port forwarding. all those reasons I told you that this is, say, a little bit tedious to create the XCF file, starting the gas, typing URLs into the browser, led to the creation of the FGL WebRun tool. The FGL WebRun tool I did show you already in the session from 2018. Today's focus will be, of course, to use the local and the remote environment, especially the remote environment, because this is, I have read also in your poll, is something you have to do. FGL WebRun creates an XCF file, it puts it to the right place, and then invokes the gas. And if you are logged in via VPN, then you can set the browser to none, and you get the right URL of the browser printed. You only need to copy the URL into your browser. How does it look like? I am switching to a Windows machine. This is my Windows development machine. You can see I have a command prompt with C /. I am now connecting via SSH back to my Mac. I'm logged into my Mac. I switch now into the wwdc directory. My FGL dir is set to a 4.0, my FGL dir is set, and I check out from scratch the FGL WebRun repository to show how easy it is to start simply from scratch. Change into the FGL WebRun directory. I could now call make demo, but this make demo would invoke FGL WebRun on my desktop. Instead, I say browser equals none and call make demo. Make demo compiles a demo.pr, it compiles a demo.4gl, and it starts the FGL WebRun application. FGL WebRun creates the XCF file for the demo, it starts the application server, and it gives me the URL for this application. The URL of the application is derived from the name of the application, just with an underscore in front. I can copy that URL, go to my browser, I paste in the URL, and the application comes up. This assumes that you are in a VPN and that your gas on the remote machine isn't firewalled. I could demonstrate another nice feature of FGL WebRun, which is have a GDC left on your desktop machine. Here's the GDC, and you export FGL server to this GDC equals lwin10.local. lwin10 is my Windows machine, 0.0. Now I don't say browser equals none, I say browser equals GDC. Call make demo. Then GDC invokes my browser on my desktop machine with the same application, same URL. The difference is I don't need to copy paste the URL. GDC makes it for me because FGL WebRun uses a small helper 4GL program to tell GDC start my browser via the exec front call. If I click on message here, I get a message on test, and I get also the message printed on standard output of the application. And because the gas is configured to display everything on standard out, I see the standard output of my application. Another example is I would like to show my environment on the remote machine, and I go to my console and I see the environment printed. So that is the benefit of FGL WebRun, because you simply see your display statements on standard output instead of searching the display statements in a gas log. Now what happens if my gas is firewalled? Then I can't simply connect to this address because the firewall would not let me in. I go into my firewall settings. I turn on the firewall. And then I go back to my Windows machine. Now I'm back to my Windows machine. My firewall is now on. If I try to reload the same URL with the gas running, I can't get in because the gas is firewalled. I could of course make a special firewall rule, but assuming that your system admin has not allowed the access to gas, you need to come up with something else. So I need to log out here. Back to my Windows machine, I start now a little SSH login with a port forwarding. This port forwarding line forwards my local 6395 port to the 6395 port on the Mac. I'm logged in into the Mac. I export FGL server to login10.local :0. Go into my wwdc demo directory FGL Webrun. Now I search this line, but I need to add FGL computer equals localhost to let the gas produce a localhost URL. Still, my GDC is reachable. Array application is coming up, and the port forwarding helps me to connect first to localhost with a browser. The port forwarding connects to the remote machine, and on the remote machine I'm connected with gas. Now a little confusion. If I click on test message, check if my message is appearing here, I don't see it. Why that? The point is the gas was still running when I logged out, and if I relog in again, then the standard output of the original gas is somewhere in Nirvana, and I can't see it anymore. To work around that, I can only kill this gas, the remaining one, and need to start another one with FGL Webrun. I can say kill all -9 HTTP dispatch. There was one. If I call it again, okay, HTTP dispatch is dead. Now run now. The same command line again. Application server runs in this terminal. I click on test message. I click on my console and I see the test message here. Small mentioning that if the gas is firewalled, potentially also the other way around, the FGL server direction to your desktop would be firewalled, though you might have to add a port forwarding for your GDC too. But that I did explain already in the 2018 talk. So please watch that talk to see how you make a secure tunneled connection to from your GDC to your to your server machine. Okay, this is how you can use FGL Webrun in various configurations. Back in the slides, I did demo the invocation of FGL Webrun in the remote mode by setting browser to none. And in this mode, you could also set gas port. Then you get the URL printed. Then I showed you what you would need to do if your gas is firewalled. You would need to use an SSH tunnel, and then also a little helper to start your program without copying the URL to your browser by using GDC, setting browser to GDC, and having the correct value set for your FGL server pointing to your desktop. Of course, the recommendation would be to use always a secure connection between the GDC and your development server. Still, there are some gotchas. I demonstrated, especially the terminal stuff, is a little bit unexpected. If you are working normally with GDC and you start FGL run, you are expecting to see the output. And now it depends on which terminal you started the gas. On Windows, currently you don't have any display output. It's only working on Unix and Mac. And sometimes if you don't redirect the FGL web run standard error output, then it might disturb in your terminal if you are with VI in a file, for example, and you get something printed from the gas. In this case, you need to call FGL web run and redirect the standard error output to an error file to avoid that. FGL-JP, FGL-SSH. These are the new tools for the desktop to help you running with the GBC in the remote configuration. It is available on our GitHub repository. It's written entirely in Genero, and it needs to be installed on the client side. This sounds a bit weird for the moment, but I will show later on that this is not so weird at all. Once installed, it really eases invoking the GBC from the remote machine. You only have to keep in mind the FGL SSH command to connect to your server instead of using SSH, and then you can run a simple 4GL program like you do with the GDC, and the GBC will appear on your desktop. The software requirements are a recent FGL comp FGL run and the JDK. How does it work? FGL SSH logs in via SSH to the remote site. It tunnels an automatic port, like the GDC does via FGL-TTY, and it starts in turn FGL-JP. This is a hybrid of GDC and GAS without any GUI. FGL-JP instead sends the Genero protocol to the desktop browser. Both FGL-JP and FGL-SSH are using the Java bridge because Java is needed to have some TCP calls which are not available yet in vanilla Genero. So how does it look like? I'm also cloning FGL-JP repository out of the box to show you how easy it is. Go to the FGL-JP directory. Of course, I need to have also the Java environment working on my development or desktop machine in order to be able to compile FGL-JP. But then I could call make demo, and a little demo comes up. You see, I did compile the FGL-P tool, I did compile the demo, I did compile the form, and then FGL-JP can invoke with the demo on your local machine. That is nothing new compared to FGL web run. If you would use FGL web run on your local machine, you would get the same easy invocation. But now I SSH into another machine. This is another Mac machine in my network. .fgl ssh -b. Now I'm logged into Bellas Mac Mini. I echo $FGL server, and FGL server is set to localhost something. I go to my wwdc directory, go to FGL-JP, say FGL run demo, and the application comes up on my desktop, and it was started on the remote machine. The FGL-JP program did invoke my local browser. It points to localhost, and this localhost address is tunneled automatically to the remote machine. I can click on display. I see the output and standard output. So that is very neat. Now, how does this happen behind the scene? And what does the -b flag mean? The -b flag means I know the remote site is a bash. If the remote site wouldn't be a bash, I can call it without the -b flag. Now I'm echoing FGL server. It's not set. Why this happens? The FGL SSH command invokes SSH with those flags, and those flags mean it tries to pass the environment variables FGL server and underscore FGL frontend ID to the remote site, but the remote site didn't accept those variables. In order to let the remote site accept those variables, I need to edit the SSHD configuration file. And this is in etc ssh sshd config. There is an entry called accept-env, and all I have to do is to add a line where I say the environment variables FGL server underscore FGL frontend ID and frontend ID 2 are accepted. Save this, restart the server, log out, log in again, echo $FGL server is set, and I can go to my demo program and can run it again. Okay, back to the slides. If you don't have a bash on the remote side and you want an automatic transmission for your FGL server environment variable, you need to edit the SSHD config files, add this little line and restart the SSH server. In case you don't have access to the SSHD config files because you are not an admin, then you could use the following commands. You could use what we call GDC tags, and this is used also in the FGL TTY configuration. You can say if the remote site is a command.exe, then you could use the @FGLNT tag. And if the remote site is a C shell, you could use the @FGLC shell tag. Another nice feature of FGL SSH is that you could use it to establish only the tunnel to the remote site. In this case, you get a little menu if you call FGL SSH with the -t flag, and it offers you to copy the right environment variables for FGL server and the rest in different syntax formats. Let's see how that works. I'm switching over to my Windows machine. I'm logged in now to my Windows machine. I have the PuTTY terminal open because I say this is my favorite terminal and I don't want to give up the comfort of this terminal. Then I could use the FGLJP tool to invoke the tunnel. I say FGL SSH -t to my Leo machine. It did build the tunnel for me. It shows up a little FGL GUI equals 0 menu where I can choose if I want to copy the environment to the clipboard, either with bash, Windows or C shell syntax. I'm copying the environment for the bash. I'm going back to my PuTTY terminal. I press the right mouse and I exported the FGL server to the right place, and now I could start my demo program in the PuTTY terminal. And it comes up. You can see my standard output in the PuTTY terminal like it would be if I would use the GDC. Okay, that's not all. In case you are on a Windows machine, on an older Windows machine where you don't have SSH available, you can use the FGL TTY which is shipped with the GDC. So if you have a GDC left on your desktop, you could use the FGL TTY to build your tunnel to the remote machine. How does it look like? FGL -B. I need the -B flag because the SSH2 transmission of the FGL server variables are not supported yet by FGL TTY. Use MBP. Now it starts an FGL TTY session. And I have also here my FGL server set. I could copy over it to via clipboard to my PuTTY terminal, or I could redirect it into a file on the remote side, the variables, so that is really not difficult to exchange the right FGL server variable then to your favorite terminal too. Of course, I could change here to my demo directory, go to FGL-JP and run the demo. So you have plenty of options to use FGL-JP. I hope you will give it a try and tell me how it feels for you. Yes, I did show you that FGL SSH can use FGL TTY and that it cannot tunnel the 3 environment variables. In this case, use the GDC tags in case your remote site is not a bash. So this is the little trick you could do if FGL TTY is not your favorite terminal. You could redirect the @FGL output in an fgl.env file, and then in your preferred terminal you can just type source fgl.env, and then you have the right environment set in your preferred terminal. Would be FGL-JP also useful for deployment in SSH mode? That is a question to you. If properly packaged, so assuming that you wouldn't have to license this FGL application in case it would be just a simple executable under the hood, it could be a replacement of GDC to start web apps via SSH. On the other hand, this functionality could be moved into GDC relatively easily, and it could invoke the system browser instead of the GDC's Chromium Web View. It also depends on your need for the desktop-specific front calls. I would be pleased if you give us feedback on that. The initial trigger for FGL-JP, by the way, was to have an in-house testing tool for the enhanced 4.0 file transfer caching in direct and SSH mode, to see a little bit what happens if you have file transferred in direct SSH mode. You could activate the FGL GUI debug variable to watch the file transfer requests. If you start an application the second time, then you would see much less file transfer compared to 3.20. FGL-deb is a tool already available since a long time, and I introduced that in my 2018 talk. I want to show in this talk a new feature, which is the -p flag to attach to a running process. This is very handy if you have a program running via gas, for example, and you simply want to attach to this process by handing over the PID to the -p flag. And it plays nicely together with the new FGL-JP tool. Of course, you can run also FGL-deb with the GDC. Small demo. I'm switching again to my Windows machine. And here I have another small surprise. If I'm setting the kiosk mode, or if I set the kiosk environment variable, then FGL-JP tries to activate the kiosk mode of the browser, or it's called also the app mode. That means you don't see any toolbars or extra menus, and you don't see the URL of the application. You might think that this is now a GDC window with universal rendering if you use FGL-JP. I'm logging into my Mac. I go to my www.dcdir. I check out FGL-deb from the repository, and I export my path to the cloned directory so that FGL-deb is in the path. If I say which FGL-deb, then okay, this is the FGL-deb in my path, and I can simply use it now. I go to my FGL-JP directory. I start the demo in the background, FGL run demo in the background. You see here, there is no decoration in the window. It looks like that this is a native application, but it's the universal rendering application running in Chrome in the app or kiosk mode. Now I'm attaching with FGL-deb to that program by calling FGL-deb-p pit 6824. And FGL-deb has attached to the little demo program. We are in the menu here right now. I say step over, and you see now FGL-deb waits for the debuggy. Here I can invoke a message, for example. Then the waiting appears here, and we are back in the debugger, can step over, can see, okay, we stepped over the test display statement. And then if you are finished with debugging, then we can go out, say detach, and I can continue with my application, or I can exit the application. So that is the FGL-deb-p flag. Of course, I can run FGL-deb with the debuggy as argument, FGL-deb demo. And then it loads immediately the demo. I can step. Now it switches to the debuggy. Now it switches back. Normally you should see here the right line selected, but for some reason the client didn't really synchronize correctly. That is a nice side effect if FGL programs or if Genero programs are used to debug Genero programs, then see immediately if something is weird. I reported this issue to the GPC team. Continue, can go out, exit, debugger exited, okay. So that is a little FGL-deb demo. Going back to slides. Yeah, by the way, it's currently used in Genero Mobile Online. FGL-deb is the debugger of this little website, which is planned to come out next. If you are with your FGL run and your browser on the same machine, and your database is also on your desktop, then things are a little bit easier because you don't have to take care about port forwarding, about firewalls, about SSH. You simply can use those tools I showed you previously, develop your applications. You could use the FGL WebRun tool with the gas together. You could use the FGL-JP tool. You could use FGL-deb or FGL-run-d or FGL-db. So that is all in all a bit easier than working remotely. One tool is left, which is still in the incubator yet. I would like to introduce to you today. This is called FGL-CM. CM means code mirror. CodeMirror is an editor available as JavaScript, and FGLCM is a wrapper around that editor. It uses the CodeMirror editor in a web component and offers you syntax highlighting, code completion for Genero programs. And it has a live form preview. Additionally, it will be programmable, or it is programmable. It has a little extension mechanism, and all this can be already inspected on this web page. Short demo now. An editor which edits your source code files like VI or like Genero Studio. It's taking a while because it needs to do the initial setup. But then you have an editor in your browser. You can have the completion. You have syntax highlighting. So let's say define string. It gives you a warning that this is unused. Okay. And I can save, of course, files. I can open files. Open, and if I open a per file, then the per file is previewed in a second GBC. So it's a kind of Matryoshka GBC, because here you have a GBC and you have also a GBC. So this is, you see, it's really a 4GL program. And what is really nice also, I have in FGLCM, I have also a block option like in Vim. And I can indent the same way like in Vim. I can change the profile. And of course, yeah, the changes in the profile are immediately reflected of what you have right here in the per. You see the visual representation on the other side. You can split it. You can split back. You can hide the preview, and you can have a full preview. So it isn't yet production ready, so I will do an announcement if I feel it is production ready. It is used in-house already to test that it's keeping your source code safe, of course. Small demonstration of this in-house tool. It takes 2 minutes. We have a tool called QA Runner, and it is used to test the GDC. If I call this tool, it is entirely written in Genero. Then a list of all our tests comes up. The list is about 2,000 lines long. We have roughly 2,000 tests in the repository. I can run simply a test by hitting enter, and that tells me if this test is okay or not. And if I click on local edit, then the FGLCM tool editor comes up. The editor has been extended to call make, call run, and call the test. It has a special menu which is dedicated to our QA actions. And of course, I can use the editor to fix, for example, issues in the code. Import. If I'm adding a line to fix the warnings. Warnings are okay. I can call make yes and make a success, and I can run this test manually, and I can run it automatically, and then I can go back to my QA Runner tool. So this is our in-house usage of the FGLCM tool. Back to the slides. For all those GitHub tools I presented to you, you can of course inspect the source code at GitHub. You can report an issue if you find that something is buggy. You could do your own forks. This is very, very easy in GitHub. And of course, you can send pull requests if you feel that something in those tools could be enhanced in the way you would like to see it enhanced. Okay, we are coming to the end. Thank you very much. I hope you could find some usage of those tools I presented. If you have any comments, please send it to me. And I hope to see you next time somewhere in real life on this planet. Thank you very much.